Here we will have a look at factorization, but first a quick introduction on how to do mathematics. Now, number and copy the examples. Ask your tutor or teacher if there are any steps that you do not understand. Number the questions, and unless you have the ability to get fit while watching someone else run, you must do the questions on your own before watching the answers. Mark your answers. If it is incorrect, write down the corrections. Make sure you understand where you went wrong. This will enable you to do better the next time you attempt a similar sum. Now for an overview on what we'll be doing in this video, first we'll start off with common factor, then difference of squares, sum and difference of cubes, quadratic factorization, an easier quadratic factorization, then the harder quadratic factorization, and then grouping. Now for the first example, we look at common factor, and we have this example over here, and what we need to do is we need to take out the common factor. So we have three terms over here, and to take out the common factor, let's start by looking at the numbers. We've got 6, 3, and 12, and we know our highest common factor between these three is 3, so we can take out a 3. And then if we look at our variables, we start with a. We've got a to the power of 3, a to the power of 2, and a to the power of 2 over here. So the highest we can take out is a to the power of 2, because that's the highest amount of a's that each term can give, so a squared. And then if we look at the b's, we've got b squared, and b. Highest one we can take out is b. And then if we look at c, we can see that this term doesn't have a c value, so we can't take out a c. Now then, if we've taken out our highest common factor, we open a bracket, and then we write down for each and every term what is left. So over here, if I take out a 3, 6 divided by 3 is 2, so 2 is left. And then if I have a to the power of 3 and I take out a squared, that means I take 2 away, then I'm left with 1a. And then if I take out a b here, I'm still left with a b, and we didn't take out the c. And then for the next term, we've got a negative, and now we took out the 3, we took out a squared, and we took out a one of these b. So the only thing that's left is just the b. And then for 12, if we say 12 divided by 3, we get 4. So this is then 4. A squared we took out, b we took out, and then c is still there. So this one is for you to try. So factorize 5, a to the power of 4, x to the power of 3 plus 15, a to the power of 5, x to the power of 6 minus 20, a to the power of 4, x to the power of 6. Alright, so the first thing we look at is 5, 15, and 20. Our highest common factor there is 5. And then we've got a's. The highest one we can take out is a to the power of 4. And then x, we've got x to the power of 3 as the highest amount of x's we can take out. We open the bracket, and what's left for the first term, we took out the 5, we took out the a to the power of 4, and we took out the x to the power of 3. So since everything is taken out, we have to put a placeholder, so we just write 1, so that when we multiply it back in, we'll still get the same answer. So 1, that's for our first term, and then plus. Now we move on to the next term. If I take out 5, 15 divided by 5 is 3, and then we took a to the power of 4, so this is going to be just an a left there, x to the power of 3, so 6 minus 3, that would give us x to the power of 3 left. And then minus, now 5 divided by 20 is 4, and then a to the power of 4, we took out a to the power of 4, so all of that goes out. And then x to the power of 6, we took out x to the power of 3, so we're left with x to the power of 3. Now question 1.2, we have 20 y to the power of 4, 30 y to the power of 2 plus 50 y to the power of 5. Now highest common factor here is clearly 10. We could take out 10 from each, and then we have our y's. Now to start off, we say we take out a 10, and then y to the power of 4, 2, and 5. So the most we can take out from each is 2, so we take out y squared. Then we open our brackets. Now from here, if I take out 10 y squared, I am left with 2, and then y to the power of 2. So notice if I multiply it back in, I'll get 20 y to the power of 4 again. And then plus 3, and y squared is taken out. And then plus 5, y to the power of 2 is taken out, so I'm left with y to the power of 3. Question 1.3, we factorize this one. Now, if the first term has a negative, it's good practice to take out a negative as well. But this one especially, because all of these terms have negative values. So we're definitely going to take out a negative. And then from 21, 6, and 9, 3 is a factor of each of these, and I believe it is the highest common factor, so we take out 3. And then with the x, we've got only an x over here, so that's the highest we can take out. And then for the y's, we've got y to the power of 3 as the highest we can take out. We open our brackets. Then if I take out a negative, I can always think about it. If you take out a negative, just change the sign. So this is just going to become a positive. And then 21 divided by 3 is 7. We took out 1x, so we're left with x squared. And we took out y to the power of 3, so this term's y is gone. And then plus, because once again the sign changes when I take out a negative. So 3 divided by 6 is 2. Then we have x to the power of 3. We took out 1x, so we're left with x squared. And y to the power of 3 was taken out, so we're left with 1y. And then here we take out a negative again, so this becomes plus. 9 divided by 3 is 3. X went out, y to the power of 3 went out, so that's our final answer. So here we've done common factors, so now we move on to difference of squares. Our first example, we've got 81m squared minus 60. Now the first thing you want to look out for, and in order to recognize difference of squares, there's always two terms. That's the first thing. And then we have that both of these terms need to be perfect squares. So we can see that 81 is 9 squared and 16 is 4 squared. So both of these plus this m squared, of course. And then finally, there has to be a negative. That's where the difference of squares comes in. All right, so what we do is we open two brackets. You can open it two brackets. Then in the one bracket we're going to have a plus, and in the other bracket we're going to have a minus. So you simply take the square root of this number. Now we know square root of 81, that's equal to 9, and we know that the square root of m squared is just m. So the square root of 81m squared would then give us 9m. So we write down the square root of this term over here, that's 9m, so we write it down here, and then square root of 16 is 4, so we write it here and here, and that's the final answer. So for this question 2.1, we have 25 and 36p squared, both of them are perfect squares. So we're going to write the square root of 25, that's 5, plus 36p squared, square root is 6p, and then 5 minus 6p. Question 2.2, here we have a fraction, but that's the same fraction. If I have the square root of a fraction, then this is simply also equal to the square root of x squared over square root of 9 squared, or 9, which then gives me x over 3. So if I have to factorize this, I simply say my square root of this fraction is simply the square root of x squared and 9, so that's x over 3 plus y over 2, and then x over 3 minus y over 2. Now for question 2.3, we have 54b cubed minus 6b. Now none of these are perfect squares, so this is another lesson that we need to also know, is whenever you're asked to factorize, always look for a common factor first. We can clearly see that there's a b in both that we can take out, and both 6 and 54 are multiples of 6. So the first thing we're going to do is just take out 6b. And then if I take out 6b, I'm left with 9b squared minus 1. And then here we have difference of squares. So this is then, we still write the 6b over here, and then we apply difference of squares on this factor over here. So this is going to be 3b plus 1 and 3b minus 1. And that was difference of squares. Now we go on to sum and difference of cubes. So for this example, now there's quite a lot of steps to remember here. So let's just start off this. We're going to have a small bracket, and then we're going to have a larger bracket. Now for the small bracket, like we did with difference of squares, we're going to take, now we have cubes, so now we're going to take the cube root of both of these terms. Now with difference of squares, it had to be a minus. This one can be a plus or a minus over here, and we start off by taking the cube root for this one. So this is going to be 4x, and then we take this sign down right there, and then this is the cube root of that is 5. Okay, so now once you've done that, you can forget about this top part now. Now we're only going to focus on this. So what we're going to do is we start with the first one and we square it. So if I take 4x and I square the whole thing, then this square goes to both of those, so it just becomes 16x squared. So this becomes my first term, 16x squared. Then I take my sign, but I take the opposite sign. So if this is a plus, then this becomes a minus, and vice versa. Then for the third term, I'm going to multiply these two together. So 4x times by 5, this gives me 20x. And then this sign is always a plus, and then we square the last term, which is 25. So just to recap on all these steps, for the first term over here, we took the cube root of this term, we took this sign, and the cube root of this term. Then we took this 4x plus 5, we took the 4x, we squared it to get 16x squared, took the sign and wrote the opposite sign over here. Then we multiplied the two together to get the 20x. Then we always write a plus here, and then we squared the last term to get the 25. Now for question 3.1, x cubed, I'm just going to write my x cubed minus 8 over here. So my first bracket, cube root of x cubed, that's just x, then the same sign, and then cube root of 8 is 2. So for my second bracket, I square the x, so that's x squared. Opposite sign is a plus, multiply together is 2x, always a plus, and square the last one is 4. Question 3.2, here we have x to the power of 3, y squared, plus z to the power of 6. Right, so we have cube roots. Now remember, when you take the cube root of a number, so here we have the cube root of x cubed, y 12, you divide your exponent with 3. So this one, so both of these get divided by 3, so this is then just x to the power of 1, or just x, and that's y to the power of 12 divided by 3, so it's y to the power of 4. That's what happens if you take a cube root. So here, taking the cube root of this, we get x y to the power of 4, then the same sign, and then if I say 6 divided by 3 to take the cube root there is 2, so z squared. Then for my second bracket, I square this. Now if I square it, x y to the power of 4, and I square it, then this 2 multiplies in with both of these exponents, so we have x squared and y to the power of 8. Then opposite sign is a minus, then we multiply these together, so this will just give us x y to the power of 4 z squared, always a plus, and then square the last one. That gives us z to the power of 4. Here we have 125 z to the power of 3 plus 64 r to the power of 6. Okay, so we have cube root of 125 is 5, and of z is just, or z cubed is z, same sign, and then cube root of 64 r to the power of 6 is 4 r, and then divided this by 3 is 2. Alright, so now we square the first one, that's 25 z squared, and then opposite sign, and then multiply together gives us 20 z, or let's start with r squared z, and then always a plus, and then square the last one. That gives us 16 r to the power of 4. Sum and difference of cubes is done. So now we move on to quadratic, easy quadratic factorization. In this example, we've got x squared minus 2x minus 24. And always remember, quadratic expressions always have 3 terms. The first, if it's in its standard form, the first is has a term with x squared, and then the second one consists of x, and the third one is just a constant. So what we do is we once again open two brackets, and then we take this 24 and we list its factors. We've got 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So what we want to get is we want to get this minus 2. So to get minus 2, we need to use one of these sets of factors. So we can see that if I say plus 4 minus 6, this will give me minus 2. So what I simply do is I say x plus 4 and x minus 6. Now for question 4.1. we need to factorize x squared minus 9x plus 20. And once again, we start off, we'll just list the factors of 20 over here. And we have 1 times 20. We've got 2 times 10. 3 can't go in. And then we have 4 times 5. And to get negative 9, I can say minus 4 minus 5. So I have x minus 4 and x minus 5. Question 4.2. X squared plus 14x plus 24. List the factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So I want to get 14. Now to get 14, we can say plus 2 and plus 12. So that gives us plus 14. So we have x plus 2 and x plus 12. And then we have a squared plus 5ab minus 14b squared. Now, in this case, we have a b and a b squared here. See, this is not a constant, but we have a b squared. So what we can do is, if this is confusing, we can treat it as a normal. Let's just do it on the side or down here somewhere. Let's just treat it as a normal x squared plus 5x minus 14 for now. Then what we would do is we'd say factors of 14, and we'd get 1 times 14, 2 times 7. I think those are the factors. And we want to get plus 5. So I'm going to say plus 7 minus 2. That would give me plus 5. So I'll have x minus 2 and x plus 7. Now we use exactly the same coefficients. So for our answer for the top one, where we have a and b, we'll have, if this is x minus 2, so this will just be a minus 2b. And then this one, where it's x plus 7, will just be a plus 7b. So just notice that we've got now a variable on both sides, where we simply still go ahead and do the normal factorization with the same coefficients. That was the easy quadratic, so now we move on to the harder quadratic. Our first example is 4a squared minus 4a minus 3, and in this case we've got a coefficient here in front of a squared. So the first term has a coefficient. Now there's two methods of doing this, and we'll do both of them. So let's start off with the first method. The first one is we draw an x, and we list all the factors of 4 on the one side. So we've got 1 times 4 and 2 times 2, and on the other side we list the factors of 3. So this one's factors goes there, and 3's factors goes on this side. So 1 times 3, and then that's the only factors there. And then what we want also to do is one of these sides needs to be flipped around. You can choose either to flip these guys around, or you can flip these around. So let's flip this side around. We've got 1 and 4, so we're also going to write 4 and 1, and here we have 2 and 2, so that doesn't matter it's still going to be the same if you flip those two around. So that's sufficient. And then we draw a line like that, and we want to get minus 4 down here. So this is the number we want to work towards. So what we're going to do is we're going to start by multiplying these sets. So you have to say these two multiplied by these two, but you cross multiply. So this 4 multiplied by 1 gives us 4, and then 1 times 3 gives us 3. Now I need to get minus 4 from these two, and so the first set won't work. So let's we can cross that out. Now let's go to the next. We say 2 times 3, that gives me 6, and then 2 times 1 gives me 2. So can I get minus 4 from these two numbers? I can say minus 6 and plus 2. That would give me minus 4. So the two sets that I used are these, where 2 times 3 is 6, 2 times 1 is 2. Now this sign over here I'm going to bring over to here. This is going to be the plus over here, and this sign I just bring over here, and that's a minus. And there is our answer. If we say 2a plus 1, so we have 2a plus 1, and then 2a minus 3. 2a minus 3. Alright, so now let's look at the second method, how we can do this. Second method is we take the 4 and the 3, we multiply together. So 4 times 3 gives us 12. And then we list the factors of 12. We say 1 times 12, 2 times 6, 3 times 4. And then we need to break this minus 4 up into one of these sets. So minus 4 can be plus 2 minus 6. So what I'm going to do is I'm going to rewrite this as 4a squared, and I'm going to break this thing up into plus 2a minus 6a. Now, one thing I need to just focus on, I can now decide if I want to write minus 6a plus 2a or the other way around. So I'm going to put the 2 with the 4 and the 6 with the 3, because they have the same factor, main factor. So we say plus 2a minus 6a minus 3. So as you can see, we just broke this up now into this. And then we're going to apply grouping, where we just look at the first two terms. Forget about the last two for now. So we take out the common factor. Our highest common factor between these two is 2a. Take out 2a. So if I take out 2a from this term, I'm left with 2a plus 1. And then I look at the next two. Now I can take out a negative. I can take out 3. And then what's left is this becomes a positive. So this is then just 2a plus 1. When I take out a negative, it changes to a positive. And if I take out 3, I have to put my placeholder of 1. Okay, and then I can take this now out as a common factor, because see, this is one term and this is one term. So my common factor, my house common factor now is this 2a plus 1. So I take out with its brackets 2a plus 1, and then what is left, open brackets, 2a minus 3. So 2a minus 3. And notice I've got the same answer as the previous one. Now for 2x squared minus x minus 3, starting with the first method, I'm just going to draw this x over here and list my factors of 2, so that's 1 and 2, and list my factors of 3, that's 1 and 3. Then one of the sides I'm going to swap around, that's 2 and 1, and then I'm going to draw this, I need minus 1, so let's start with 2 times 1 is 2, 1 times 3 is 3, so to get minus 1 I say minus 3 plus 2, and then I see I've used 1 times 3 and 2 times 1, so then this sign goes over here and this sign goes over here, and then my factors are 1x plus 1 and 2x minus 3, so this is then x plus 1 and 2x minus 3. Okay, that's the first method. Now let's just do it the second method in case you've chosen to do it that way. So 2 times 3 is 6. Let's just do this, 6. My factors of 6 are 1 times 6 and 2 times 3. To get negative x, I'm going to say plus 2 minus 3. Alright, so here I'm going to start with my 2x squared minus x minus 3, and then I'm breaking up this minus x into minus, so I'm going to put the 3 with the 3 and the 2 with the 2, so plus 2x minus 3x minus 3, so there I've broken it up, and then start with factorizing. So here I can factorize out a 2x, and what's left here is just x plus 1, and then over here I can take out a negative 3, so what's left is x plus 1, and then I can take out this x plus 1, so x plus 1 comes out, and we're left with 2x minus 3, and we have the same answer once again. Question 5.2, start off with 6p squared plus 6p minus 8, and we draw our cross, and then 9 times 1, we list the factors of 9 times 1, 3 times 3, and then we list the factors of 8, so we have 1 times 8 and 2 times 4, and then one of these sides we need to swap around, so I'm going to swap this side around. You're also going to write 1 times 9, and I don't have to rewrite the 3 times 3, so I want to get plus 6. So what I'm going to do is I'm going to start with 9 and 1, so 1 times 1 is 1, and 9 times 8 is 72, so that's too big, and then we have 9 times 4, that gives us 36 and 2, so that's also too big of a difference, so 9 and 1 can't work. Then we have 3 times 8, so that gives us 24, and 3 times 1 is 3, so this is also not going to work. Then we have 3 times 4 is 12, 3 times 2 is 6. Now 12 and 6 can give me 6, so I can say 3 times 4 is 12, and 3 times 2 is 6. So to get plus 6, I need to say plus 12 minus 6. And then I put the minus over here and the plus over here. And then I have 3p minus 2. So my answer is 3p minus 2 and 3p plus 4. 3p plus 4. Now for the second method, I'm just going to copy this again, 9p squared plus 6p minus 8, and then we have 9 times 8, that gives us 72, and then to list the factors of 72, we have 1 times 72, we have 2 times 36, and then 3, so let's say 72 divided by 3, this gives us 24, so 3 times 24, and then 72 divided by 4 is 18, so 4 times 18, and then 5 can't go in there because a number ending with 0 and 5, that's multiple of 5, and then 6, let's see, 72 divided by 6, and that's 12, so 6 times 12. Now if I want to get plus 6, then I can say plus 12 minus 6. So rewriting this as 9p squared, I'm going to put the 6 with a 9 and the 12 with a 8. So this is going to be minus 6p plus 12p minus 8. And then we just look at the first two terms, and we can factor out 3p, and what's left is 3p minus 3 goes into 6 two times, and we take out the p, so that's just minus 2. And then we can factor out a 4, so we say plus 4, and if I take out a 4 here, I'm left with 3p minus 2 once again. So now we have the same factors over here. We can say 3p minus 2 taken out as the common factor, and then we're left with 3p plus 4. And that's our same answer as the previous method. Now for question 5.3, here we have 16y minus 8y minus 3. We start off with the first method where we list our factors. First of 16, we've got 1 times 16, 2 times 8, and 4 times 4. And on this side, we have 1 times 3. So one of these we need to swap around. So let's swap this side around. We say we also have 16 and 1, and 8 and 2. And then we want to get minus 8. So starting with the first set, we've got 3 and 16. So not going to work, so these we can cross out. Then we have 8 and 6, also not going to give us negative 8, so those we can cross out. Then we have 12 and 4, that might work. So you have 4 times 3, which gives us 12, and 4 times 1, which gives us 4. Now to get negative 8, I need to say minus 12 plus 4. So this plus goes over here, and this minus goes over here, and then we can just put the y's over here, then that's our answer. We've got 4y plus 1, so 4y plus 1, and then 4y minus 3, 4y minus 3. Alright, and then once again, second method, 16y squared minus 8y minus 3. So multiply 16 times by 3, 16 times 3, this gives us 48, so 48, and the factors thereof is 1 times 48, 2 times 24, 3, I think this is 3, let's just make sure of that one, 48 divided by 3 is 16, so 3 times 16, then 4 times 12, and here we can see if we want to get minus 8, we can say plus 4 minus 12. So here I'm going to break this term up. I'm going to say 16y squared, and here we're going to put, let's put the 4 and the 16 together. So we say plus 4y minus 12y minus 3, and then we have take out 4y from the first two terms only, and we're left with 4y plus 1, and then from the second set of terms we can take out a negative and we can take out 3, then we're left with 4y plus 1, and here we take out 4y plus 1 as our common factor, so 4y plus 1 comes out, and then what's left is 4y minus 3. So this means we are done with the second set of quadratics. We now go on to grouping. Now for example 6, we have 10a squared xy minus 32 plus 4a minus 80a xy. So this is an example of grouping, and with grouping, the way you can identify it easiest is it's always 4 terms. Now this 10a squared xy and so forth, what we normally do with grouping is we first ignore the second 2 terms, and then we just take out a common factor from the first 2 terms. Then we move on to the next set and we take out a common factor there, and then we have to have the same factors that we can take out again. Now as this one is here, it might not necessarily leave you with the same factors after you factorize the first time. And let's just see what happens if we go straight forward and do that. If we take out common factor for the first 2, we can only take out 2. Then we're left with a squared xy minus 16. Then we move on to the next set. We can take out a 4. So if we take out a 4a, we can take out 4a. So if we take out 4a plus 4a, and then we're left with 1 minus 20xy. And now you can see that this and this isn't identical. So that means what we need to do is we first need to rearrange. So this isn't going to work. We first need to rearrange some of these terms. Not always, but just when it doesn't work out when you factorize it first. So as you can see, this term and this term kind of looks the same because they both contain a, x, and y. So let's put them together. Let's start with writing it as 10a squared xy, and then write down minus 80a xy. Now just note also that the sign always goes with the term when you rearrange them, and now we need to decide which of these 2 remaining terms needs to go first. So if I look at these 2, my smallest number is first. So what I'm going to do the same here. I'm going to put my smallest number first, which is 4. So I'm going to put plus 4a minus 32. So let's see if it works out now. If we just look at the first 2 terms and we factorize out, we can factorize out a 10, and we can factorize out a, x, and y. A, x, y. So what is left is the 10's gone, so only a is left for the first term, minus 8. And then over here, moving on to the second set, we can take out a 4. So if we plus 4, we can take out, after we took out 4, we're left with a minus 8. And as we can see, we are left with identical factors, so now we can factorize again. We take out a minus 8 with its brackets, open bracket for what's left. So this 10a xy plus 4 is left. Alright, so normally this is where it ends, but as you can see, this 10 and 4 also still contain a common factor. So we can take this, we could have actually taken out 2 with this a minus 8. So if I take out a 2 here, then I'm just going to put the 2 in front. Then we have a minus 8 and 5 a xy plus 2. So question 6.1. Here we have 10, so let's just copy it over here. 3 minus 5x squared a minus 6yx plus 3ay. Alright, now let's start with the first 2 terms. If I take out, I can take out 5, I can take out x squared from both of those. Open my brackets, I'm left with 2x, and then minus the 5 is gone, the x squared is gone, minus a. And then from the second 2, I can take out a negative. Normally when this first term is a negative, we take out a negative. We can take out a 3, and we can take out a y. And then we open our bracket, so the negative's gone, so 6 divided by 3 is 2, and the y is gone and the x remains. And then if we take out a negative, the sign changes. So this plus then changes to a minus. And then we have, we took out the 3 and the y, so only a is left. And here we can see that we have our two identical factors. So we factorize that out as 2x minus a. And what is left is 5x squared minus 3y. Now for question 6.2, we have to factor now. As you can see, the grouping has already been done. The first factors has been already taken out. So I'm just going to rewrite it here. 3x y minus 3 minus y, 3 minus y. Now, the only problem here is we've got y minus 3 here and 3 minus y. So it's not identical. Although it's quite close. Now, what needs to happen is we need to swap these two terms around to get it to be y minus 3. But we can't just, because of this negative over here, we can't just flip it around, because 3 minus y isn't equal to y minus 3. What we need to do is we need to take out a negative first. So if we take out a negative, we're left with negative 3 plus y. And then we have, then we can swap these two around. We have y minus 3. Because remember, if you swap terms around, you have to take the sign with the term. So if I want to swap these around, shorthand way is simply to, if there's a negative here, is to swap them around and change the sign in front. So this then is equal to 3x y minus 3, and then change the sign to a plus. And this becomes y minus 3 as well. And then we can take out y minus 3. And what is left is this 3x plus y. 3x plus y. Question 6.3. We're going to factorize 9a minus 6bx minus 18b plus 3ax. Okay, so if I look at the first two terms, I can see the only thing I can take out is a 3, and there's no variables that look alike. So I'm going to go ahead and first rearrange so that I have at least some variables that are similar. So I'm going to put my a's together. As I can see, there's an a and there's a a. So I'm going to put my a's together, and I'm going to put my b's together. So starting off with that, we have 9a plus 3ax. And then for the next two terms, in this case, we've got 9 bigger than 3. So I'm going to put my 18 first, which is bigger than 6. So minus 18b minus 6bx. All right, so here we have between 9a and 3ax, we take out 3a as our highest common factor. So 3a comes out, and then we're left with 3 plus x. And here we can take out a negative, and then we can take out a 6, and we can take out b. So if I take out 6b, I'm left with, or minus 6b, I'm left with plus 3, so just a 3, and then take out a negative, it becomes a positive. 6 is gone, b is gone, so only x remains. Now, here we see that our two factors are identical, so we take out 3 plus x, but actually look at the other factors. We've got a 3 and a 6 over here as well. So we can take out a highest common factor of 3 also. So I'm going to take out 3 and the 3 plus x. So those are the factors that could have been taken out from this term and this term. So what is left then? If I take out this 3 and I take out this 3 plus x, then the only thing that's left is the a. And then minus, so I took out a 3, so there's 2 left, 6 divided by 3, and there's a b left because the 3 plus x is also gone. So this is generally just 3 brackets 3 plus x, a minus 2. And we have now worked through all the subsections, so this is it for factorization.